Let's work through a quick but important example from thermal physics. The question asks us to calculate the average kinetic energy of air particles in a laboratory at 22 degrees Celsius. The key idea to remember is this: temperature is a direct measure of the average kinetic energy of gas particles. So if we know the temperature, we can calculate how much kinetic energy each particle has on average. For a gas, the average translational kinetic energy of a single particle is given by the formula. Average kinetic energy equals 3/2 times Boltzmann's constant times the absolute temperature. Boltzmann's constant has a value of 1.38 times 10 to the negative 23 joules per Kelvin. Now, temperature must be in Kelvin, not degrees Celsius. So our first step is to convert the temperature. 22 degrees Celsius becomes 22 plus 273, which gives 295 Kelvin. Now we substitute into the formula. We take 3/2, multiply by 1.38 times 10 to the negative 23, and multiply by 295. When we calculate this, we get 6.1 times 10 to the negative 21 joules. So this tells us that each air particle has an average kinetic energy of about 6 times 10 to the negative 21 joules at room temperature. Now let's finish with the big idea. Because the average kinetic energy is directly proportional to temperature, this means that as temperature increases, the average kinetic energy of the particles also increases. When the temperature goes up, the particles move faster, collide more frequently, and transfer more energy during collisions. If the temperature decreases, the particles move more slowly and their average kinetic energy decreases. So temperature isn't just a number on a thermometer. It's a direct measure of how energetic the particles are.